Hey guys, welcome to lesson 715, day 2. Today we're going to practice converting between degrees and radians, plotting those on the unit circle, and then doing a little bit of stuff that we already have been doing regarding the coordinates. So we first have to keep in mind that when we're going between radians and degrees, there are two conversion factors we use. They are either pi over 180 or 180 over pi. Okay, hopefully you remember this from yesterday or yesterday's video. Which one we use depends on whether we're going from degree to radian or radian to degree. So this first one you use when you're going from degrees to radians. The second one you use when you're going from radians to degrees. Okay, so let's see what that looks like in action here. For 120 degrees, if I want to find that in radians, all I got to do is multiply that 120 by pi over 180. Right, and again, here it tells us that this is the conversion factor we use when we're going from degrees to radians, so I'm just following that. Once we set that up, we're like, okay, well, when we multiply a number by a fraction, you pretty much just by default multiply that number to the top of the fraction. So this is what we end up with. At this point, we pull out our calculator, and we want to completely ignore pi. We're going to keep pi in our answer, and that's why we're not putting it in our calculations. So once I do 120 divided by 180, let me get this bigger. 120 divided by 180 gets me 0.66667. Then I press this math button and press enter on this frac function. That's going to turn my decimal into a fraction. So then I get 2 over 3. So my answer is then 2 pi over 3. So basically that 120 over 180 turned into 2/3, and that pi just hangs out there the whole time. All right, let's do another one. 330, so we'll do 330 times pi over 180. And so just like before, that means we'll do 330 divided by 180. Let me write that. All right, so 330 divided by 180 gives us 1.8333, and then we press math, enter on frac, enter again, and this gives us this 11 pi over 6. Make it bigger so you guys can see. So in my answer, I'll have 11 over 6 with the pi in there. All right, and you know, let me just move this down actually. Okay. So that's how you convert between the two. Now regarding plotting these points on the unit circle, all I expect of you right now is to know what these points are, these dots, in degrees. So we, just because we know we've been working with the unit circle a while, we know these main 5 points already. 0, 90, 180, 270, 360. These you should have well memorized by now. Besides those, these other dots are the ones like right in the center of each quadrant. So this one is 30, then it goes up in 15-degree increments. Then there's always going to be a 30-degree gap between like the end ones. All right, so then we hit 90 and then plus 30, so this is 120. This is plus 15, we get 135. This one is 150, 180, and then plus 30 gives me 210. Plus 15 gives me 225, and we get 240 here. All right, the last portion here, 300, 315, and 330. All right, so when we're plotting, we know that for 120, we'll just put a dot where 120 is. And then for 330, we'll put a dot where 330 is. All right, so that is how you go between, or go from degrees to radians and plot on the unit circle. So my next two examples are going from radians to degrees. So this time we'll use the other conversion factor. Instead of using pi over 180 like we did in here, we'll use 180 over pi because we're going from radians to degrees. So we'll take our let's go skinnier. So we'll take our 2 pi over 3 and multiply that by 180 over pi. A good way to remember which conversion factor goes with which is that when you're going from radians to degrees, your goal is to get rid of pi because you never want any pi with your degrees. So by having pi on the bottom of our conversion factor, they get to cancel. So really you end up with 2 times 180 on the top and just that 3 on the bottom. So that ends up being what you want to type in your calculator. All right, 2 times 180 over 3. And we get, oops, I did not type that right. 2 times 180 over 3. Let's try that again. All right, we get 120. So that tells me that 2 pi over 3 in degrees is 120. All right, and I know from up here that that's going to be right this first dot after 90, so I'm not going to bother to relabel all of them. All right, let's do the next one. So 5 pi over 4, we're just going to go ahead and multiply that just like before by 180 over pi. So the pi's cancel. I end up with 5 times 180 over 4. And that's going to give me an answer of, let's move this over, all right, 5 times 180 divided by 4, and that's 225. So this is a 225 degree angle. So let's just plot that one over here. I just use this as a guide. All right, that is all the practice with going between radians and degrees. So next up is some coordinates. This is a very base level coordinate problem, and you have to remember that the coordinates we're going to be asking for are just x and y values, pretty much. Okay, so coordinate is typically on a graph x comma y, and what that means is x is the horizontal distance and y is a height. All right, so that tells me that these two are my horizontal distance and my height. So in trig, this horizontal distance is represented by cosine, and then this vertical distance, this height, is represented by sine. So when I ask you for coordinates in trig, I am asking for the cosine. Oops. Let's do it in red or blue. Cosine of our angle, in this case it's 225, and then our sine of our angle. So sine of 225. And this is just a calculator game, so I'm going to go ahead and type that in the calculator where you can see it. Cosine 225 and sine of 225. So cosine of 225, sine of 225. So I find that my coordinates, the x coordinate is negative 0.707, as the y coordinates is the same. So negative 0.707, comma, negative 0.707. That is my answer. Now the reference angle is always referring to the angle inside of the triangle, right here, okay? So, let me draw that a little better. So to get that angle, I just have to use a little bit of logic. So I know that my big angle is 225. So by the time I get here, I reach 225 degrees. I also know that here is 180. And so I can recognize that this angle is the space between 225 and 180. So all I have to do is 225 minus 180, and this gives us a 45-degree reference angle. Now I would be done, except it's asking for radians, so I'm just going to go ahead and convert this to radians using my conversion factor. So this becomes 45, oops, oh wow. This becomes 45 pi over 180. And so, of course, in my calculator, I just need to type 45 over 180. And this gives me 0.25. I'll go to math frac, and that's 1/4. So I end up with 1 pi over 4. You can also just write this as pi over 4. If it's just a 1, you don't really need it. If you keep it though, it's fine. All right, and that is the reference angle. All right, on to the next. So here, this is a problem regarding the Pythagorean theorem. I gave you the sine of this triangle. And so we're gonna go ahead and label appropriately. All right, so if I said the sine is -1/2, that refers to my height. I gave you the height. Because I'm looking for coordinates, right, remember that that means cosine comma sine. Now I've already provided you with the sine, it's -1/2, so you have half the answer, but we don't have what the cosine is, and that's what we need to find. So the cosine is the horizontal distance, so I will put an x there. I'll put a 1 on this hypotenuse, that's always 1. And so let's go ahead and set up our Pythagorean theorem. We know it's a squared plus b squared equals c squared, and the hypotenuse is always c. These two are always a and b. The legs, I don't care which is which in that case. C, as long as c is right, it doesn't matter which one's a and which one's b. So then you just plug in accordingly. Okay, plugged in my a, plugged in my b, plugged in my c, and then you simplify. -1/2 squared is 1/4, and 1 squared is 1. At this point, I'm going to go ahead and subtract 1/4 from both sides because I want to get the x term by itself. All right, so now to finally get x alone, let's square root both sides. So I get the square root of 3 over the square root of 4. Now I can't square root 3 any nicer, so I'll leave it like that, but the square root of 4 is 2. Now I would say that we're done, but because your triangle is on the left side, in order for this to be accurate, we need to turn it to a -√3 over 2, because cosine is always negative on the left side of the triangle. Because left side of circle. All right, so my final answer then would be -√3 over 2 and a -1/2. This is exactly how you would write your answer. All right, one final question here. This one is pretty simple. All you have to do here is plot your points from your unit circle to the graph, but you have to just kind of estimate what you think these degrees are. So point A kind of looks like it's at 120. You have to pick degree measures that are actually like on our axis. So this one I would definitely go ahead and call 120. Okay, so I'll go ahead and find 120 on my x-axis. Here it is. And then I will just trace it up to where my graph is, and that's where I'll plot my point. All right, so let's try another one. This one's quite literally at 180. So I will put 180 on the x-axis. I will trace it back to my graph, and I'll plot my point right here. All right, one more point. We have, that one is looking like it's at about 360, so, or sorry, not 360, 330. So I'll find 330 on my axis, and I'll trace it to my graph. And again, I just eyeballed it. I kind of looked at it and I was like, that looks like 330, that looks like 120. And you can kind of tell because we're only focusing on those like 3 dots in the middle. So And that's it. You're done with that problem.